Today let's check the percentage purity of calcium carbonate. So this is the calcium carbonate we're talking about. So let's check the first question and see if we can do it. So this is the first question. Suppose a sample of seashells has a mass of 5 grams. The carbon dioxide is collected while the sample is heated. When no more gas forms, the mass of the carbon dioxide that was released is 0.66 grams. Then determine the percentage purity of calcium carbonate in the seashell. So this is the balanced equation. So you can pause the video and try it out. So now let's check. We are given the mass of the sample, and then we're also given the mass of carbon dioxide. So let's check now. This is the carbon dioxide that we're talking about. So what we must do now, we must calculate the number of moles of the carbon dioxide. So this is what we're going to say. The number of moles of carbon dioxide, CO2, is equals to it's mass, the small letter m, over the molar mass. So now, what is the mass? The mass is given as 0.66. So we're going to say this is 0.66 grams of carbon dioxide. So now, the molar mass, we are going to say the molar mass for carbon is 12 plus oxygen, that is 16 times 2 because it's O2. So now this is what we're going to have. So we can say this is 0.66 divide. This one is going to give us 44, the molar mass. So now the number of moles is going to be 0.66 divided by 44. That is going to give us 0.015 mole. So this one is the number of moles of the carbon dioxide. Now, since we have the number of moles of carbon dioxide, now we can use the mole ratio to get the number of moles of calcium carbonate. So now we're going to say the mole ratio is calcium carbonate, CO3 is to the carbon dioxide, CO2. Now let's check the ratio. The ratio is 1 is to 1, the coefficient. So since it's 1 is to 1, it means that the number of moles of this one is equal to the number of moles of this one. So now we're going to say the number of moles of carbon dioxide is equal to the number of moles of calcium carbonate, and is equals to what? 0.015 mole. So now it's telling us that the number of moles of calcium carbonate now is 0.015 mole. Then now from here, now we can calculate the mass of calcium carbon dioxide, of calcium carbonate, since we have the number of moles. So we're going to say mass is equals to number of moles multiplied by molar mass. So we took this formula from here, we just cross multiply. And then the number of moles is 0.015. Then the molar mass of calcium carbonate. So we go to the periodic table. Ca, that is 40, plus the carbon is 12, plus the oxygen, that is 16 times 3. So now this one is 0.015 multiply. So this one is going to give us something like 100, if I'm not mistaken. So the molar mass is going to give us 100, and then when we multiply this one by 100, it's going to give us 1.5 5 grams. So this one is 1.5 grams is for calcium carbonate. So since now we have the mass of calcium carbonate, so the question said we must determine the percentage purity of calcium carbonate. So now what are we going to say? We're going to say the percentage purity. Okay, let's open the space. Percentage purity, I'll just write percentage purity is equals to, so the formula says this is the mass of the pure sample, and then we divide by the mass of impure sample. Then this is percentage, we just multiply by 100. So now what is the mass of the pure? The mass of the pure calcium carbonate is this one as 1.5, and then the mass of the impure is this one. This is the impure calcium carbonate, which is 5 grams. So it's given on the statement that is 5 grams. So now we're going to say it's 1.5 divided by 5, and then we multiply by 100. So the answer is giving us 30%. So it means that our percentage purity of that calcium carbonate on a seashell is equals to 30%. Let's check the next question. Okay, so let's check. You can pause the video if you like and try it out. So a sample of impure calcium carbonate of unknown mass required continuous supply of strong heat to decompose according to the following equation. So as you can see, this is the equation. Now after the decomposition of the reaction, 11.76 grams of CaO or calcium oxide was produced. So the percentage purity of calcium carbonate is found to be 80%. Then calculate the mass of the impure calcium carbonate. So what are we going to do now? Now we're given the percentage purity, we must calculate the mass of the impure calcium carbonate. So what are we going to do? We're given the mass of CaO. This is our CaO. We're given the mass of that one. So what must we do? We calculate the number of moles of this one. So we're going to say number of moles is equal to mass over molar mass. So the mass of this one is 11.76 divide the molar mass. We're going to say Ca is 40 plus oxygen, that is 16. So this one is going to give us 11.76 divide 40 plus 16, that is 56. So when we divide this one, it's going to give us 0.21 mole. So this one is for CaO. So this is the number of moles of CaO. Now, since now we have the number of moles, we are going to use the mole ratio, the same as the last one. So the mole ratio is Ca as for calcium carbonate, CaCO3 is 2 CaO. So now let's check the ratio. The coefficient is 1 is to 1. So now we're going to say 1 is to 1. So since the ratio is telling us that 1 is to 1, it means that the number of moles are equal. So Now we're going to say the number of moles of CaO is equals to the number of moles of CaCO3, which is equals to 0.21 mole. So since now we have the number of moles of the calcium carbonate as 0.21, now we must calculate the mass of calcium carbonate. So now the mass is equals to number of moles multiplied by the molar mass. So the number of moles is 0.21, and then the molar mass of calcium carbonate, calcium is 40 plus the carbon is 12 plus oxygen, that is 16 times 3. So as you can see, it's the same as that one. So now let's say this is 0.21 multiplied. This one is giving us 100. And then when we check, now the mass is going to give us 100 times 0.21. That is 21 grams of calcium carbonate. Sorry. So since now we have the mass of calcium carbonate, this is the pure mass. This is the pure mass. So the question said we must calculate the mass of the impure. So this is the pure mass that we get. So what are we going to say now? We are going to say, now we're going to say the percentage purity, is equals to, this is the mass of the pure, simple, and then we divide by the mass of impure, the mass of the impure, and then we multiply by 100. So now let's check. The statement said the percentage purity of calcium carbonate is found to be 80%. So it means that the percentage purity now is 80%. So we're going to say this is the 80% that we're talking about. And then the mass of the pure simple is the mass that we calculated. We found 21. So we're going to say 21 over. This is the mass of the impure that we're looking for. And then we multiply by 100. So now let's say we divide the whole equation by 100. So we divide by 100, and then 21 over mass is equals to, so 80 divided by 100 is going to give us 0.8. And then now let's say we cross multiply. So we're going to have 0.8 is equals to 21. And then we divide both sides by 0.8. So the mass is equals to 21 divided by 0.8 is going to give us 26.25 grams. So this is the mass of the impure simple that we're looking for. So thank you for watching, and please don't forget to subscribe.